This is Activity 1, Fraction, Multiplication, and Division from Lesson 12, using graphs to compare relationships. And this is just some review of multiplying and dividing with fractions. And it's important that you gain some level of comfort doing these operations, because this is going to come up all the time throughout your entire use of mathematics, whether in school or outside of school. You have to become comfortable with, with fractions. So the first problem is what's 2/3 times 1/2? And that can be read as what's 2/3 of 1/2. So if you look at 1/2, what's 2/3 of that 1/2? So I'm going to draw pictures throughout this. And you should practice doing that because it gives you an idea of what the problem is asking you to calculate rather than just looking at numbers and doing the calculation and not really understanding what the answer is. So draw a rectangle, have two halves. This is 1/2 and this is the second half. And this is 2/3 of that first half. So how much is that 2/3, or are those 2/3 of the whole thing? Well, if you divide the half into thirds, then that's like dividing the whole thing into sixths. So that 2/3 of 1/2 is equal to 2/6 of the whole thing. So how much is 2/3 of 1/2? It is 2/6, and 2/6 actually simplifies to 1/3. This is 1/3 of the whole rectangle, 2/3 of the whole rectangle, these two pieces, and 3/3 of the whole rectangle, those two pieces. So 2/3 of 1/2 equals 1/3. So let's calculate this a couple of different ways. You can use the commutative property and rewrite 2/3 of 1/2 as 1/2 of 2/3. So that's just moving the 1/2 over here and moving the 2/3 over here. Well, if you have two of anything and you say what's 1/2 of those two things, it's always one of those. So now I have two of these things called thirds. So what's 1/2 of those 2/3? 1/2 of those 2/3 is equal to one of those 2/3, or 1/3. Now we're going to do this using arithmetic in just a moment. You're going to see that these twos cancel out. But here's the 2/3, 1/3, 2/3, and what's half of those 2/3? Well, it's just one of them. So the answer is 1/3 of the whole rectangle. And you can look at this also as 2/3 times 1/2. You can rewrite this as 2 times 1 divided by 3 times 2. So write them over the same fraction bar. So it's 2 times 1 over 3 times 2. Then use the commutative property to move the 2, to switch the 3 and the 2 here. So this 2 is over this 2. Well, 2 divided by 2 is equal to 1. That means that you can cancel those 2's out, and you're left with this 1/3. And this is probably the most straightforward way to do it, and the easiest way to do it, and what most teachers will say is, oh gee, just cancel out these 2's and you're left with 1/3. But without these drawings as a basis to understand the problem, you're just doing some arithmetic and getting the answer of 1/3 and not really understanding why it's 1/3 of this whole rectangle. So put some effort into it. Try to do some drawings. We're going to do drawings down here as well. Now this next one, I'm going to use this same approach, 2/3 of 1/2. I'm going to use that same approach down here, 4/3 of 1/4. I'm going to make a drawing, but it takes a lot more space. So I'm going to do that on the next page. So 4/3 of 1/4. Well, first of all, I need to draw 1/4 because I'm going to take 4/3 of that 1/4. Well, what's 1/4 look like? Here's the whole rectangle, and here's 1/4 of that rectangle. And then I want to see thirds. I need to be able to see these thirds because I want 4 of them. So thirds of 1/4, you just take the 1/4 and divide it up into 3 equal parts. So this is 1/3 of 1/4, 2/3 of 1/4, 3/3 of 1/4, and that makes sense. This is all the whole 1/4, so 3/3, which is the same as 1. 1 of 1/4 is 1/4. 1 times 1/4 is 1/4. But I need 4/3. This only gives me 3/3. So where am I going to get the 4th third? Well, I'm going to take the rest of this whole rectangle. I'm going to divide each of those fourths up into thirds. Now, jumping ahead a little bit, how many total parts do we have? Well, it's 4 fourths, each divided up into 3 parts. So that is 12. So we have 12 total parts. So this is 1 third of 1/4, 2 thirds of 1/4, 3 thirds of 1/4, and 4 thirds of 1/4. So 4 thirds of 1/4 is equal to 4 twelfths. And 4 twelfths, what fraction are these 4 twelfths of the whole rectangle? They are 1/3. So 4 twelfths simplifies to 1/3. So 1/3 and 1/3. So now you have some idea of that if you look at 4 thirds of 1/4, it's a piece of this whole rectangle, or a piece of whatever you're talking about, that's a little bit larger than 1/4. It's 1/3 of 1/4 larger than 1/4. And so you should say these words. You should just practice visualizing what's going on. So 4 thirds of 1/4 equals 1/3. And many teachers will just say, hey, just cancel out those 4s, you're left with 1/3. But you don't really have a very good feel of what that 1/3 is if you just do the cancellation and write the answer down as 1/3. It's 1/3 of this whole piece, and it's 4 thirds of 1/4. All right, so now I'm going to do the next way of solving this problem is just copying what we did up here for 2 thirds of 1/2. So 4 thirds of 1/4. Well, if I'm going to use the commutative property, and so I'm going to switch this around, so it's 1/3 of 4 thirds. I'm sorry, 1/4 of 4 thirds. If I flip it around and just look at 1/4 of 4 for just a second, 1/4 of 4 of anything is one of those things. You have 4 apples. Give me 1/4 of those 4 apples. You're going to get 1 apple. 1/4 of 4 of anything is one of those things. In this case, it's 1/4 of 4 of these things called thirds. 1/3, 2 thirds, 3 thirds, 4 thirds. So I have these things called thirds, and I want 1/4 of them. Well, 1/4 of them is just one of those thirds. So 1/4 of 4 thirds equals 1/3. Same answer we got back here. 4 thirds of 1/4 is 1/3. All right, so another way to look at this is just copying the way that we did it up here for 2 thirds of 1/2. So you can write this problem as 4 times 1 divided by 3 times 4. Use the commutative property. So line up the 4s, and those cancel out because they are equal to 1. 4 divided by 4 equals 1. And 1 times anything equals that thing. So 1 times 1/3 equals 1/3. So you're using the commutative property, and what we say is cancel out the 4s because they equal 1. So you can look at those as just 1, which in essence removes it from the multiplication problem. All right, so 4 divided by 1/5. So now we're doing the opposite operation. The inverse operation of multiplication is division. So 4 divided by 1/5, what you're asking is, how many of these fifths are in 4 whole things? Well, 1/5 of something, it means that you've taken that rectangle in this case, and I've divided it up into 5 equal parts, and one of those parts is 1/5. Well, how many fifths are there? Because that's what that says, is 4 divided by 1/5 is how many fifths do I get out of these 4 things? And that's what division means. You're measuring out how many fifths you have. Or 1 divided by 1/5 is how many fifths do I get out of this one thing? Well, you get 5 of them. So there's 5 fifths. And using arithmetic, you can use the inverse operation of division, which is multiplication, and the multiplicative inverse of 1/5 is 5 over 1. It's also called the reciprocal. So you're going to multiply by the reciprocal. So you're going to use the inverse operation. If you use the inverse operation, you have to use the multiplicative inverse. So it has to be the inverse and the inverse. You can't say, I'm going to multiply by 1/5. You get 1/5 as an answer, which is wrong. That's why the drawing helps you think through it. So 1 times 5 over 1 is equal to 5. So how many 1/5 do I get out of 1? I get 5 of them. But I have 4 of these. I have 4 units in this problem. So 4 divided by 1/5 is 4 times 1 divided by 1/5. If you want to look at it that way, I'm going to do this 4 times. And so that's 4 times 5 is equal to 20. Because we just figured out that this 1 divided by 1/5 is 5. 4 of those is equal to 20. All right, so this is just using the arithmetic now. So 4 divided by 1/5, I'm going to use the inverse operation. So I'm going to use multiplication, which is the inverse operation of division. If I do that, I have to use the multiplicative inverse. It has to be the inverse and the inverse. So the multiplicative inverse of 1/5 is 5 over 1. 4 times 5 over 1 equals 20. 4 times 5 equals 20. So again, the answer is 20. The answer is 20. All right, so 9/6 divided by 1/2. Well, if I divide anything by 1/2, I'm going to get twice as many of those parts. But in this case, actually, let's look at this a little bit differently. First, we'll get to that second way in just a moment. This is asking how many halves are in 9/6. So I have 9/6 of something. Well, first of all, what does 9/6 mean? Well, if I take a rectangle and divide it up into six equal parts, this is 6/6. So the whole thing, but I need 9/6. So I need 3 more, so it's 1 and then a second whole rectangle, and I need 3 more 6. So how many halves is that? So you can count them. This is 1 1/2, 2 1/2, 3 1/2. So the answer to the question is going to be 3. How many halves are there in 9/6? That answer is 3. There are 3 halves in 9/6. All right, so you divide by 1/2, it's going to equal 2 times as many parts. Whenever you do division by dividing something by 1/2, then you're saying, then you will calculate that there's 2 times as many of those parts. So 9/6 divided by 1/2, I'm going to use the inverse operation, which is multiplication, and the multiplicative inverse, just like up here. Inverse operation, multiplicative inverse. So 9/6 times 2 is equal to 18/6. Notice it's twice as many sixths. I had 9/6, now I have 18/6. I have twice as many, so 18/6 is equal to 3. Same answer is over here, but it's a different picture actually. So 9/6 is equal to, you can simplify 9/6 to 3 halves. So factor out the 3's. 3 times 3 divided by 3 times 2. 3 divided by 3 is 1, so those cancel out. You're left with 3 halves. So what's 3 halves divided by 1/2? 3 halves divided by 1/2. You're going to use the inverse operation, which is multiplication, the multiplicative inverse, which is 2, or 2 over 1. And so now you're going to end up with twice as many halves. You're going to end up with 6 halves. And 6 divided by 2 is equal to 3. So the same problem, just using 9/6 simplified to 3 halves. Now let's go into this in a little bit more detail. This is measuring out halves. You're taking out 1/2, another half, 3 halves. So I can measure them out. But what if I have a crate of apples and I count, and that crate is divided up into 2 equal parts, and I count the number of apples I have in half the crate, and let's say those apples are spread evenly out over the whole crate. So if I have, let's just say I have 9 apples in half the crate. How many apples do I have in the whole crate? Well, I'm going to have 18 apples in the whole crate. So if you look at division as things placed into equal groups, 9/6 divided by 1/2 can be thought of as 9/6 per 1/2 of a group. So picture 1/2 of a crate. So in that half of a crate, I have 9/6. So here's the 9/6. So then how many of these 6 do I have in the whole crate or the whole group? I have twice as many. I have 2 times 9/6. You can see using the inverse operation and multiplying by the multiplicative inverse. So 9/6 times 2 gives me 18/6. So 18/6 per group. And how many whole units is that? That's 3 units per group. 18 divided by 6 is 3. So I get that answer of 3, but now it means something different. It means 3 whole units, whereas before it meant 3 halves that I was measuring out. So different ways to look at it. That's why it's important to do these problems in context or within a story, so you see what's going on. So I'm going to simplify that 9/6 to 3 halves. So 3 halves divided by 1 half. Look at it as 3 halves per half of a group. 3 halves per half of a group means that there are 3 halves in this half of a group. Well, then how many halves are there in the whole group? And you see all of this kind of work with slope of a line. You're just going to use fractions a lot as you get into linear equations. So 3 halves per 1 half of a group means that you have twice as many halves for the whole group. So 2 times 3 is 6 halves per whole group. Well, 6 halves per whole group is equal to 3 units. 1, 2, 3.